Hello, and welcome to this walkthrough of my senior design project. Before we get started with the movie, I would like to give you a little bit of background so that the movie makes sense. First, the problem statement. The objective of this project was to design a device that aligns two silicon or glass wafers and then applies heat, force, and voltage in order to bond them together. The device must be able to align the wafers with a precision of around 10 microns. In addition, it must be able to apply a voltage of up to 1,000 volts, a force of up to 200 pounds, and a temperature of up to 400 degrees Celsius. The solution that my group came up with consists of two parts. First, the wafers are aligned using a device that I refer to as the chuck. Once the wafers are aligned using the chuck, they are placed in a separate device that I refer to as the squish. The squish bonds the wafers by applying the required voltage, force, and temperature to the chuck and the wafers inside. Now I think we're ready to start the video. The first step in making a bond is to align the wafers. Alignment is done using the chuck and an alignment device already present in a clean room here at Tufts University. Here's the chuck separated into pieces. The first piece is the bottom piece. You can see a ring of ceramic washers that we use for electrical insulation during the bonding process. Next is the middle piece. You can see the thermocouple hole we use to monitor temperature, along with 5 holes that we pull a vacuum through in order to hold the wafers in place during alignment. And here's the top piece. You can see a series of small holes. These small holes allow us to pull a vacuum through the top piece and hold a wafer to the underside, and you'll see that later in the video. Finally, here's an example of a typical silicon wafer that could be aligned and bonded using our device. Now the various pieces of the chuck will be placed into the aligner. The first piece to go in is the bottom piece, and that sits there for most of the alignment process. It comes more into play at the end when everything needs to be locked into place. Next comes the middle piece. The middle piece is attached to a vacuum line to pull air through the holes mentioned before. The middle piece sits on the center post. The center post is moved using micro-positioning tools. The tools allow the center post to rotate, move forward and backwards, left and right, and up and down. There are several set screws built into the middle piece that allow it to be secured to the center post. Once the middle piece is secure, the first wafer can be put in place. Again, this wafer is held in place by the vacuum being pulled through the holes on the top of the middle piece. Now the second wafer can be put in place. Eventually, a vacuum will be used to pull this wafer up and hold it to the underside of the top piece, and you'll see that in just a minute. Now the top piece is brought out. The center post mentioned before is now raised so that the wafers are making contact with the bottom of the top piece. Now a vacuum is pulled through that series of small holes and the top wafer is now stuck to the bottom of the top piece. Now the wafers can be aligned by moving the bottom wafer relative to the stationary top piece. To do this, the microscopes are pulled out and focused on the wafers. Alignment marks on the wafers are used to align the wafers with extreme precision. Once the wafers are aligned, the center post is brought up, pinching the wafers and holding them in place. Wing nuts are used to bring the bottom piece up, squeezing everything in place and preventing the wafers from shifting out of alignment. The vacuum fittings can now be removed, and the entire chuck can be taken out of the aligner. You're now left with your 2 wafers aligned and securely in place in the chuck. Now the chuck can be brought over to the squish for the actual bonding process. Heat is provided by a hot plate. Force is applied by the piston screwed into the crosspiece. Thermocouples are put into the chuck to monitor temperature at the bond site, and an electrode is screwed in to apply the required voltage. The user can now go to the computer and input a temperature, force, and voltage profile. The system is completely programmable, and the computer is able to vary all 3 parameters over time. After waiting for an hour or 2, the user will be left with 2 bonded wafers.